Hello, Honors Algebra 2. This is lesson 2.3, Histograms and Percentile Rank. So I'd like you to watch this short lesson on histograms. Should be a nice review of some topics that you've seen before, and then you'll complete a follow-up assignment based off these definitions that I've showed you. So let's start with just the basic definition of a histogram. A histogram is a graphical representation of a data set in which data is organized by numerical intervals to show overall shape and distribution. So a histogram basically can only be a numerical representation. There is a very stark difference between a histogram and a bar graph. You're probably used to seeing something called a bar graph. This is an example of a bar graph down here. A bar graph is only for categorical data, meaning that it can't be represented through numbers. For instance, eye color. Eye color is not numerical data, and so therefore it would have to be a bar graph to show the frequency or the amount of people with black, brown, blue, green, or hazel eyes. Student height, however, would be a histogram, because height is something that is numerical and can be measured, and so you can arrange your x-axis by interval. Here are my intervals down here, and decide how many people fall within that particular interval. So histograms can only be numerical, while bar graphs is probably what you studied when you were younger, and like lower grades you would do surveys, you know, what's your favorite food and pizza, and that's not numerical. But histograms can only show intervals of numerical data. We arrange things in histograms according to bins, and bins are just bars on a histogram whose height represents frequency. So you're going to hear me talk a lot about bin height. Bin height, essentially, in this particular histogram, bin height for this first bin would be 2 people that fall into the height interval of 145 to 155 centimeters. And my bin height here would be 6 people. My bin height here would be, looks like 9 people. And then finally, I have a bin height of 3 people that fall into that final interval of 175 to 185. You do have to make a determination on these boundaries which bin you're going to place items that match that boundary value. I would always like you to go bin right. And what does that mean? Bin right essentially means that a value of 175 would be in the right bin. So I would expect to find a person that is 175 centimeters tall in this bin right here. I would expect a person that's 155 centimeters tall to be in this bin right here, the bin to the right. You have to be consistent when you make a histogram, otherwise it's kind of misleading as to which values are in which bins. The more things you put into a bin, the higher that the bin will be. I have two other histograms here to kind of just help you determine why we use histograms and kind of give you a picture as how they could be manipulated to show different trends in data. So we have somebody whose name is Shatevia, you gotta love our book, took a random sample of 50 students who own iPods at the high school and asked how many songs they stored. The two graphs were constructed from the data table. So, ladies and gentlemen, number of songs is numerical, so therefore we can use a histogram representation to answer several different questions. So, for instance, what is the range of the data? Well, we obviously know that range is going to be max minus min. So take a moment and check your table, see if you can find the max value and the min value off of your table. I think 1013 looks like it's going to be my max value. My min value looks like something in the 700s. I think it is 765. So if you subtract those two values, 1013 minus 765, you get your total range, which is 248 songs. The question is, would you be able to calculate that range just simply by looking at the histogram? And the answer to that question is no, you would not be able to. You cannot calculate that because you don't really know what's in those bins. So while the max down here is indeed 1013, which would be in this bin right here, and the min we know is in this bin, you actually don't know which is in each of those bins to make that particular determination. And so that's one of the downfalls of a histogram. Your bin width will be 50 total songs. And how you know bin width is by simply looking at your interval and figuring out what is the total interval. How can you tell that the graph accounts for all 50 values? You would look at your bin heights and simply add up your total. So, ladies and gentlemen, right now I'd like you to look at those bin heights, add up your total, and verify that it does indeed equal 50. So we take a look at different bin heights here. Looks like this one is 4, this one is 6. I'm thinking this is a bin height of 13. This might be a bin height of 18, maybe a bin height of 7, and then finally a bin height of 2. And I believe if you add up all those values, you get 10, 20, looks like you're going to get a total of 50 values. 4 plus 6 plus 13 plus 18 plus 7 plus 2 equals a total of 50. Why are the columns in graph shorter in graph B? If you look at your bin widths in graph B, so we said the bin width of each graph, for graph A it was 50 songs, but for graph B, if you take a look, it's only an interval of 10 songs. And so as you decrease bin widths, then your bin heights are going to change. So why are the columns smaller in graph B? Because the bin width is smaller. Which graph is better at showing overall distribution? I think overall distribution would be graph A. There is a balance between determining the best bin width to represent your data, but if you look at graph A, you do see this really nice bell curve shape happening in graph A. It's not that you don't see that in graph B, but I think it is definitely more apparent in graph A. However, when you decrease the bin widths, you can see that you can identify gaps and clusters in the data a lot better than the overall distribution in graph A. So for clusters and gaps, we would say graph B would definitely be the better choice. And then finally, you can answer percentage questions pretty easily. What percentage of players have fewer than 850 songs stored in their iPad, or iPod rather? So if we look at 850 songs, that follows right here along these two bins. And we know that I generally go bin right, so 850 would be in the right-hand bin. So it looks like we have a total of 10 out of 50 students who have 850 songs or fewer on their iPad. Just divide that out, and you'll get your final total. %. A quick analysis of two different histograms, and hopefully you can see the main difference between both of them. The second thing I'd like to show you a little bit is percentile rank. Percentile rank is a numerical value that represents the percent of data lower than or less than the given data point. Especially when you look at very large amounts of data, you want to be able to compare yourself to all the other data pieces or the other people that are contained within that data set. And so a lot of times when you get your standardized tests back, it'll say that you scored maybe in the 85th percentile. A lot of people think that means that you got a B on, for instance, the SAT. That's not what that means at all. It means that out of all of the people that took the SAT, you did better than 85% of them. Not the same as, but better than 85% of all of the people that took the test. You're always counting what comes above and below. In this case, for percentile rank, it's going to be the below the given value. So in example B, it says the data used in this histogram have a mean of 34.05 and a standard deviation of 14.68. In part A, we have to approximate the percentile rank of a value 2 standard deviations above the mean. We have to actually figure out what 2 standard deviations above the mean really is. If my mean is 34.05, we're going to add 2 standard deviations to the mean. We get a value of 63.41. So we're going to figure out in part A the percentile rank of the value 63.41. And so we need to figure out essentially how many values fall below 63.41. Below what we know for sure is 63.41. If we take a look at our histogram, 63.41 falls into this particular bin. Do we know how many values are in that bin? Sure, we know there are 2. But can you tell me with certainty that those points are above or below 63.41? You really can't. So therefore, we're going to cut the histogram right here and count up the values that are below that bin from 60 to 65. Maybe those 2 values are below 63.41 and should be included in this calculation, but we really don't know for sure. And so we're going to just err on the side of caution. We're going to ignore that bin and count up everything that's below. So if I start to look at my bins, this has a bin height of 2. We have a bin height of 4, a bin height of 5, a bin height of 9, two more at 4, 2 at 3, a 2, and a 1. So take a moment and sum up those values. I'm getting 37 total values inside this percentile rank. And then it looks like we have an overall total of 40 values. And so to find the percentile rank of 63.41, we would simply take 37 divided by 40. And we get a total of 92.5. For percentile rank, you're always going to round down. If you round up, then you are assuming that 63.41 is higher than values than it may not be. So our final answer would be the 92nd percentile, and you will always write it in that format. So we would say that a value of 63.41 is in the 92nd percentile, which means essentially that 63.41 is better than or higher than or larger than 92% of the data. 63.41 is greater than 92% of the data. And that's what it means to have that percentile rank. And so, ladies and gentlemen, it's really important that you stop and think about 92nd percentile. It's not about how well or how good you did. It's about how were you compared to everything else. Take a minute, pause the video, and I'd like you to read example C and see if you can answer the questions on example C. So at a large university, 1,500 students took a final exam in chemistry. Frank learns that his score of a 76 out of 100, which we know would be a 76%, puts him in the 88th percentile. How many students scored lower than Frank? How many students scored higher than Frank? We know that Frank is in the 88th percentile. Which means he did better than 88% of the students. So if he did better than 88% of the students, we know that there are a total of 1,500 students. We could take 1,500 times 0.88 and get a value. We know he did better than 1,320 students. Not bad for Frank. How many students scored higher than Frank? Interesting question. Remember that percentile rank only tells us how Frank did better than other students. To know how many students scored higher, you would have to know how many people did better than Frank, which we don't know. We don't know because we don't know how many people scored the exact same thing as Frank. So therefore, how many scored higher? This is not possible until we know how many people scored the exact same as Frank. Part B says Mary scored an 82, which placed her at the 95th percentile. Describe Mary's performance as it compares with others in the class. This means that she did better than 95% of the students. So we'd assume that she probably had a pretty high grade unless there was a considerable curve. The highest score on the test was a 91%. What percentile rank is associated with this score? If the highest score is a 91% overall total, we know that a person with a 91 on the test, a 91 out of 100, we know that they did the best and they did better than everyone else. They don't tell us if there were multiple people that scored a 91, but it doesn't really matter in this case because it's all about who you scored better than. In this case, you would have scored better than 100% of the people, so you would be in the 100th percentile. Every student who scored above the 90th percentile received an A. How many students received an A? You would simply take your 90th percentile. We know there were a total of 1,500 students. 90% times 1,500 would give you your total value. 1,350. So percentile rank is all about who you did better than. And since it's who you did better than, we might have to revisit letter C. Initially, you probably thought that this person would be in the 100th percentile. But if you have the highest score in the class, technically, you didn't do better than one person. And that one person would have been yourself. So therefore, it is not possible to be in the 100th percentile, and therefore is a trap type question. This person we know would have to be in the 99th percentile because no matter what, you can't do better than yourself. Be careful with this trap of a problem. Question, is it possible to be in the 0th percentile? Let's think about what that means. Is it possible for you to do better than 0% of the people that took the tests? And the answer is yes, because you could be the lowest score. Now, being in the 0 percentile doesn't mean you got a 0%. Maybe the lowest score on a test was an 85%, but you'd still, unfortunately, be in the 0th percentile because you did not do better than anyone. So this is lesson 2.3, histograms of percentile rank. I encourage you to go back and rewatch any part of the video you need to rewatch again. You're now going to complete a short assignment on percentile rank and histograms. I will see you guys on Thursday when I'm back at work.